Hi, I'm Doug Waldo. Welcome to the JAZ Computer Tutor Program for Introduction to Computers and DOS. This video course allows you to learn at your own pace. Just stop the tape whenever you want to refer to the JAZ Computer Tutor Manual, review part of the videotape, practice an example on your own, or take a break. If you prefer, you can watch the videotape and practice the examples later. The JAZ Computer Tutor Manual guides you step by step through the same examples as the videotape. And the first part of this course is designed to acquaint you with what a computer is, what its component parts are, how it works, and what it can do for you. You'll also learn briefly about the history of the personal computer. And finally, you'll learn about some of the accessories you can use with your computer and how to choose a computer for your needs. Now, once you're well acquainted with the computer, the second part of the lesson will teach you about the DOS, the Disk Operating System. In effect, DOS brings your computer to life and allows you to do all the things you bought the computer to do in the first place. Without DOS, your computer would be worthless. And this lesson will show you how to use the many powerful DOS commands, turning your computer into the valuable tool you expect it to be. Now, let's review the table of contents in this manual. This is an outline of the structure of this course. And by the end of this lesson, you will have learned everything you see listed here. Notice that a transcript of this lesson is included in the manual, so you can take the lesson with you wherever you go. During this lesson, I'll be showing you various parts of a computer system which have been disassembled. Do not attempt this at home. Disassembling your computer could damage your computer or possibly cause injury to you. Well, if you're ready, let's get started with Chapter 1. So now we come to the million-dollar question. Just what the heck is a computer anyway? Well, I think it best to start out with a very simple definition. The computer can best be described in this way. The computer is an electronic device which takes information, the input, in the form of letters and numbers, processes that information according to rules set down by its user, the programming or software, and presents the results, the output. This might sound like a very simple definition, but this is all that a computer really does. It might be helpful at this point to give you a few examples. First, consider the common utility bill you receive in the mail each month. And most of these bills are now processed by computers, so let's see how they do it. Well, first, the amount of water, gas, and electricity you have used is collected by a utility employee who reads your meter. This data is then input into the computer by a data entry person. The data is processed according to the program the computer is running. In this case, that means that your bill is calculated according to your usage and the current rates. Now, finally, the total charges to you is sent as output to a printer, which types out your bill. Now, let's consider another example. How does a word processing system work? Word processors are very helpful and are used routinely in many offices. Again, the process is very simple. First, the data, in this case the letter or memo being typed, is input or typed into the computer by the user. Then this data is processed according to the rules set down in the word processing program by the people who created it. In other words, the program tells the computer to keep the words between the margins, to put one line after another, etc. Finally, the words are output to the computer's screen so that the user can see what he or she is typing, or to the printer at some later time. Okay, so now you have an idea of how a computer works in general, but what really makes up a computer? What are the parts? You'll find out in a moment. The most basic part of any computer is the integrated circuit, or chip as it's called. Here's an example of a chip. It looks just like a piece of black plastic with some metal parts sticking out. And that's exactly what it is, although some chips are made of a black ceramic material. You can see that the chips are also different sizes. In fact, chips come in many different sizes, starting from about the size of the fingernail on your little finger up to a size which would just rest nicely in the palm of your hand. But if a chip is just a piece of plastic, how does that make a computer work? The secret is what you are looking at is really not the functioning part of the chip at all. That part is hidden inside. The parts you can see serve to hold the circuit, protect it, and provide these metal legs to connect to other parts of the computer. Each of these legs is connected to a different point on the circuit inside. If we could open this chip up, what we would see would be a small silver or gray square, which is usually a little bit larger than the end of a pencil eraser. This is the integrated circuit. In the biggest chips, this might be about the size of a postage stamp. The integrated circuit is made of a piece of specially prepared silicon. The silicon has very tiny lines cut into it which act like the wires in an electric circuit. However, because silicon is a semiconductor, a material which can be made to either conduct or not conduct electricity, parts of the chip can be made to act like transistors. Now, transistors are a type of electronic switch which can be turned on or off. It is these parts which actually make the computer the marvel it is. It's hard to imagine, but on some chips, as many as 100,000 or more tiny transistors have been constructed. The manufacturers of these chips perform this magical process by first making a large drawing of the lines they want to form on the chip. Then, with special lenses forming a type of large camera, the pattern is created on the chip surface with light. Special chemicals react with the light to eat away only the parts of the chip which will form the lines. In this way, lines much, much smaller than a human hair are created on the chip. The chips connect with each other through the metal legs on the chip. The legs are soldered onto or fitted into special sockets on the circuit boards. Now, circuit boards have layers of copper conductors in them which form the connections between the legs on the different chips. In addition, different chips serve different purposes. Some chips are made to store numbers, while other chips manipulate them, and still others perform other functions. Chips, however, are not the only key elements in a computer. Magnetic storage also plays a large role. Many different kinds of chips make up what we know as the computer. However, computers serve another purpose which we have so far overlooked. They can store and retrieve incredibly large amounts of data. In fact, many times the input or the output or both come from or go to some kind of storage device. To do this, computers need another type of device, magnetic storage. Even though a chip can store data, it has to constantly have power supplied to it or it will lose or forget the data. In addition, chips are still expensive and bulky compared to magnetic devices. So what is magnetic storage? Well, you've been using it for years, even if you've never used a computer. The common audio cassette is a magnetic storage device. Computers also use tapes. By recording in a special way, digitally, computer tapes can hold large amounts of data, much more than the number of chips, which would take up the same volume of space could, and it's done less expensively. But tapes are not the last word in magnetic storage. Since tapes are exposed to the atmosphere, they get dirty, even if only a little bit. This limits how small one tiny piece of data can be on the tape. You can see if a speck of dirt about the same size or larger than one piece of data were to be on the tape when the computer tried to read that piece of data, the dirt might prevent the data from being read. This would cause an error. So we need something which will prevent this problem. The solution is the hard disk, sometimes called the fixed disk or Winchester drive. Now here is part of a hard disk. This is called a platter, and there may be half a dozen or more of these in each hard disk assembly. This brown surface is made of the same material as the surface of an audio tape. However, fixed disks are either sealed or are supplied with well-filtered air and are hard instead of flexible. This means that dirt will not be present on the surface, and that the device which reads and writes that data onto the disk can be much more precise. Consequently, the pieces of data can be much smaller, and thus the disk can hold more data. Now, a good way to picture this is by comparing it to handwriting. Imagine I gave you a 3x5 card and told you to write the alphabet as many times as you could on it. Then I gave you a large felt marker to write with. With the marker, you might be able to write the alphabet only once or twice. However, if I were instead to give you a very fine pencil, you could probably write the alphabet 30 times without much effort. This is like the difference between a hard disk and a tape, or floppy disks. Floppy disks, like this one, are similar to hard disks but act more like tapes. This is because they are both flexible and exposed to the atmosphere. Consequently, they store about 1/10 the amount of data as one hard disk platter. Well, now you know about chips and magnetic storage, but you may still be asking how the computer works. In the next chapter, we'll find out what is actually happening on those chips. Okay, so now you know what a computer is, what it does, and what it's made of. One thing still remains. How does it work? Well, describing in detail how a computer operates is much too complex for this lesson, but we can give you a brief overview of the basics. We talked before about chips and how the parts of them act like very small transistors. Well, each of these transistors is really a very tiny switch. That is, it can be either turned on or it can be turned off. By adjusting which switches are on and which are off, the computer does the things you tell it to do. Recall that some chips have hundreds of thousands of switches. Well, fortunately, computers can set these switches very quickly. It's easy to imagine how these switches can be used to perform different actions in the computer. For example, if some data is to be sent to the printer, the switches connecting the memory, where the data you want to print is, to the port, where the printer is connected to the computer, could be turned on, allowing the data to be printed out. Somewhat like turning on a garden hose and allowing the water to flow through. Here's another example. Each time the computer reads or writes data from the floppy disk, one of these little switches causes a small red light to come on to let you know this is happening. Of course, it's not this simple inside the computer, but the idea should be clear. However, the part that might be hardest to understand is how switches can be used to store things like numbers and letters. In order to explain this, we need to cover two other items: binary numbers and the ASCII table. First, we need to go over some terminology. Since each of the little switches in the chips can be in two different positions, either on or off, we use a special type of number system called binary notation. It's called binary because it's a base 2 number system rather than the base 10 we're used to with decimal numbers. This means that each digit in a binary number system can only be one of two numbers, 0 or 1, instead of the 10 we use in decimal numbers. For example, the number 3 in base 10 is represented as 0, 0, 0, 0, 0, 0, 1, 1 in base 2, or binary. You don't need to know how this system works at this point in time, but you should understand how the computer uses it. The number 1 can be represented by the on position of a switch, and the number 0 by the off position. So the computer can store the number 3 with switches as off, 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 on, on. We call each position in the number, or each switch, 1 bit, and a group of 8 bits is called a byte, terms which you have probably heard before. Well, this is a great way to store numbers, but how about letters? For letters, a table of ASCII codes has been developed. As we just saw, the computer can only deal with binary numbers. To work with letters, the computer translates every letter of the alphabet into a corresponding number. The list of numbers and letters is called the American Standard Code for Information Interchange, or ASCII, pronounced ASCII. Using this list, for example, the letter A is the number 97 in decimal form, or 011000001 in binary. This table of ASCII codes should be in your basic manual, which came with your DOS package. Since 8 of these little switches, 1 byte, can store 1 letter of the alphabet, 1 byte equals 1 character. Many times you will hear the term kilobyte, usually written as KB. A kilobyte is about 1,000 bytes. More precisely, it is equal to 1,024 bytes. Now, when you hear that your new computer has 640 kilobytes of memory, you know that it means it could store about 640,000 letters in all of that memory. But a computer must and does do a lot more than simply store numbers and letters. In order to do what it does, it must have programs or software which tell it what to do. Software is a type of code which tells the computer how to operate. Without software, the computer couldn't do anything. Software can be packaged in many different ways. It may be stored on a floppy disk, a hard disk, a tape, or even stored in the memory chips themselves when they are made. The term firmware is sometimes used to designate software which is stored in chips rather than on a disk or tape. So how does this software work? Well, software is stored along with your data in all those little switches we just talked about. It sets the switches up in certain ways to route information and control the different parts of the computer. For example, when you type on the keyboard of a computer, each keystroke closes a little switch under the key. This switch is connected to other switches which together send out a number that is different for each key, called the scan code. This number is determined by the firmware loaded in your computer when you bought it. This code is passed along through other switches to the processor, which looks at the scan code and determines what key you typed. Remember that the processor always must work with letters as numbers instead, so that at this point the value inside the computer is the ASCII code for the character you typed. The software you are running then might decide to display the letter on the monitor. To do this, it controls other switches which pass the ASCII code along to other parts of the computer which would display the character on the screen. Now this all seems very complex, and it is. But to you, the user, what you should remember is that software, along with your data, are both stored in memory in the little switches etched onto the chips in your computer. And without the proper software, your computer wouldn't be much more than a paperweight, unable to even bring itself to life when you turned it on. But keep in mind that not all software is the kind you must load off of a disk or tape. Some is stored in the computer itself, even as it's being made. And this, as I said before, is called the firmware. Now I'll give you some ideas of what your computer can do for you. So if computers are so great, what can they be used for? Well, there are three main uses for personal computers: word processing, spreadsheets, and databases. I'll explain what each of these is. First, many people use computers as word processors. You may already be familiar with this term because word processing is so popular. However, for those of you who aren't, it's very simple. Word processing is essentially like using a typewriter, except that this typewriter can do much more than just take what you type and print it out. Word processing programs have features beyond the most advanced typewriter. They allow you to easily store documents and bring them back later to be used again or to be revised. They can check your spelling and even correct mistakes for you. With a word processing program, you can take one part of your document, say a sentence or paragraph, and move or copy it to another part of the same document or to a different document. Advanced word processing programs will even let you mail out the same letter to many different people and addresses, what we call mail merging, and what you most often see as junk mail in your mailbox. Because of all these features, word processing programs have become one of the hottest selling types of programs on the market and a function of the computer which is very important. For those of you who know accounting, spreadsheets are probably familiar. In accounting, a spreadsheet is a table of rows and columns which is used to help keep track of figures and calculations. This is an example. In this example, the salespeople make 20% of their sales as commission. However, say you'd like to know how much they would make if it were 22.5% instead. On a paper spreadsheet, this would mean more manual calculations and some erasing. But by using a spreadsheet program on a computer, this is not necessary. With a spreadsheet program, the computer is first told that the commission is supposed to be calculated as 20% of the sales column for each salesperson, and it remembers this formula. To change the numbers, you simply tell the computer you now want the commission to be 22.5% of the sales, and all the figures are recalculated on the screen before your eyes in a fraction of a second. Of course, you can also save spreadsheets to be used later and print them out on paper. Spreadsheet programs are so popular in the business world that many companies find them indispensable, and for good reason. The final major type of programs you might think of using are databases. Databases are similar to something just about everyone has used, a phone book. In your phone book, you probably have people's names, phone numbers, and addresses. Well, these same things could be stored in a database. In a database, we call the different parts fields and records. A field is one piece of information, the name or the phone number or the address. A record is a group of fields related in some way. For example, all of the information I just mentioned for one person. So each person in your phone book would be a separate record made up of different fields, which contain the information we want to store. You might think, however, that if this is all that a database can do, you might as well just keep using the old phone book. What really makes a database work is what it can do with the information it holds. For example, a small company might set up a database which holds the names, addresses, and past purchase history of all its customers. When a customer makes a purchase, that transaction is entered into the database. Then, at the end of the year, the company can use the database to total the fields which contain the purchase amount to see how much has been sold. They can use the addresses to print out a list of the major customers, or they could use the list with a word processing program to do a mail merge, which might inform their customers of an upcoming sale, something you probably all have received in the mail as well. Databases are powerful because they can retrieve information quickly and in the order you specify. They can do calculations on the data they keep and print out reports in any format you choose. For these reasons, database programs are probably the most popular use for large computer systems and a major use for small ones, too. These three types of programs are just a hint of what computers can be used for. Many people use their computers for games, communicating with each other and larger computers, drawing, creating music, and a myriad of other things, some of which were not even dreamed of a couple of years ago. One use which is becoming very popular is desktop publishing. Now, this is essentially a very advanced word processing package with tremendous capabilities. For less than $10,000, you could become your own publisher, producing high-quality documents. You will find that many thousands of programs are available for personal computers. There are programs for making architectural drawings, as well as educational programs to teach you everything from foreign languages to mathematical skills. There are financial programs to help you do taxes, balance your checkbook, or track a portfolio. And business programs which help you to design forms and fill them in, track projects, or do accounting like general ledgers, accounts receivable, and the list goes on. Obviously, your computer can do a great deal. This isn't surprising, considering the number of new computers being sold each year. By now, you should have a good idea of what a computer is, generally how it works, and what it can do for you. Now it's time that we get more specific. We're going to be talking about personal computers, or PCs. Although it's difficult to define just what makes a PC different from other types of computers, in general, a PC is usually small enough to fit on a desktop, sometimes giving them the name desktop computers. We'll talk about the parts of a PC, what they are, and how they work, about how to hook one up and get it running, and about the operating system called DOS. Before that, however, you need to know a little bit about the history of the personal computer. Back in the early 1980s, the first personal computers came on the market. These included products from Apple and various kit-type computers. However, it wasn't until 1982 that the release of the IBM PC stabilized and made popular the personal computer market. This first PC was based on the 8088 processor. It wasn't long before companies like Compaq took the initiative to upgrade the PC with computers based on the 8086 processor. These early PCs were soon followed by another IBM product called the XT. It featured greater expansion capabilities as well as a hard disk. Clone or compatible computers became even more prevalent by this time. Then came the release of the IBM AT. This machine was based on a new processor, the 8286. It ran faster than the PC or XT and was more powerful. However, more power was on the way. Last year, Compaq introduced the first computer based on an even more powerful processor, the 8386. These machines, now available from IBM as well as others, are even faster than ATs and represent the state-of-the-art in personal computers. The newest IBM machine deserves a special mention. These machines have the designation PS2, which stands for Personal System 2. These machines are different because some of the models have what is known as a micro-channel bus. This is a form of expansion slot, which is different from all the other computers. It allows much greater power and versatility, but cannot use standard expansion cards. However, as more and more expansion card manufacturers change over to the new format, this will be less of a problem. Now you know a little bit about the history of the PC. Next, we'll look at the component parts of these machines. The most important part of a PC is the system unit, also sometimes mistakenly called the CPU, Central Processing Unit. The CPU is only one part of the system unit. The system unit contains the processor, the memory, the power supply, hard and floppy disks, and the interface cards for other parts such as the monitor. Here we see a typical system unit. This is a system unit from a PC XT computer. If we look inside, we can see many things. First, looking way down on the bottom of the case, we see the motherboard, the circuit board which holds all the chips which make up the computer. This is also sometimes called the system board or planar board. Now here is a typical motherboard removed from the system unit. This large chip here is the processor or CPU. IBM-compatible computers can have one of 4 different processors designated by a number code: the 8088, 8086, 8286, and 8386 in order from least powerful to most powerful. As I said before, the first PCs had 8088s. Then other manufacturers built compatible computers based on the 8086. The IBM AT was then released, which used the 8286, and recently 8386 computers have been released. In general, the 8286 is about 3 times faster than the 8088, and the 8386 is about 3 times faster than the 8286. A common term you will hear when speaking about CPUs or computers in general is clock speed. The clock speed is the heartbeat of the computer. The faster it is, the more work the computer can do. Clock speeds are given in megahertz, or millions of beats per second. It can range from 4 to 10 megahertz for an 8088, 6 to 16 megahertz for an 8286, and 16 to 25 megahertz for an 8386. Also on the motherboard is the memory. This can be seen here as an orderly row of chips. Memory comes in 2 types, RAM and ROM, which stand for Random Access Memory and Read-Only Memory, and there are significant differences between them. RAM is where your programs are stored when they are running and where your data is stored when the computer is on. RAM memory is volatile memory. This means that it must have power or it loses data. Thus, all RAM memory is lost when you turn off the computer. This is why you must store all your data onto a hard or floppy disk when you are done working before you turn the computer off. ROM memory, on the other hand, will not and cannot be erased. In fact, it cannot even be used to store your data or programs. What it does is hold the programs which run the computer. The firmware we spoke of before in the PC world. These programs are called the BIOS, or Basic Input-Output System. These programs make the different parts of the computer work together properly. The amount of RAM memory your computer has is important. Memory sizes are expressed in kilobytes or megabytes. A kilobyte is 1,024 bytes, and a megabyte is 1,048,576 bytes. Most computers have between 128 kilobytes and 2 megabytes of memory. Since a program must be loaded into RAM memory to run, and since programs vary widely in the amount of memory they need, The more memory you have, the wider the range of programs you will be able to run. In addition, the data you are working on is usually also stored in RAM, so the more memory you have, the more data you can work on at a time. On the other hand, the size of the ROM is set by the manufacturer and is usually of little importance to most buyers. In addition to coming in different sizes, RAM memory also comes in 3 different types: conventional, extended, and expanded. For an explanation of these, please read your manual. These explanations will not be covered on video. You may want to read the definitions a few times to fully understand what is being explained. The best option for most users who want to add memory is to purchase a board which supports all 3 types of memory. This will allow you to round out your systems to 640 kilobytes, use programs effectively, and still be ready for the future. The other prominent feature on this motherboard are these connectors. These are called expansion slots, and they are used to attach expansion cards. A typical expansion card looks like this, and it slides into the slot just like this. You'll notice that there are 2 different types of slots on this motherboard. The short slot is called an 8-bit slot because it can transfer 8 bits of data at a time. These type of slots are the kind used in PCs with 8088 and 8086 processors. The longer slots here are called 16-bit slots because they can transfer 16 bits at a time. These types of slots are used with 8286 and 8386 processors. This and most other computers with 8286 or 8386 processors make available both types of slots because the majority of expansion cards are of the 8-bit type, which don't always fit in 16-bit slots because the card interferes with the additional connector. Expansion slots are very important to the future uses of your computer. They are needed to connect monitors, printers, modems, mice, or other types of devices to your computer. You should carefully choose what cards you put into the slots and how many slots are available if you are buying a new computer. It's also important to remember that some slots are always taken up just to run the computer itself. For example, slots are usually needed to run the monitor, hard disk, and floppy disks. So you should find out how many slots will be available after the computer is fully prepared and ready to run. If we look at this particular expansion card, we can see that it has 2 connectors on the back. These connectors are used to connect devices such as printers. This is a parallel serial card, and these are the parallel and serial ports. Ports are places where you can connect devices. IBM-compatible computers typically can use 2 serial ports and 3 parallel ports. The serial ports are called by the names COM1 and COM2, while the parallel ports are called LPT1, 2, and 3. The difference between serial and parallel ports is simple. Serial ports can transfer data both into and out of the computer. They send the data out 1 bit at a time in single file order. This means that they are relatively slow, but are versatile. Parallel ports, on the other hand, can only send data out of the computer, but they have the advantage of sending out data 8 bits at a time. Thus, they are much faster than serial ports. Serial ports are typically used for modems, mice, and printers. However, parallel ports are used almost exclusively for printers, since printers are not capable of inputting data to the computer, which is good, since parallel ports are not capable of receiving input. Another thing you'll notice inside the system unit is this large silver box. This is the power supply. It provides the electrical power needs of the computer. When purchasing a computer, you should look for a large power supply to prevent problems in the future. This is because each addition you make to the computer, whether it be a new expansion card, disk drive, or hard disk, takes more power. If you run out of power, you have limited the capability of your machine. A typical computer comes standard with a power supply from 60 to 200 watts or more. To run a computer with a hard disk, you probably should have at least 100 watts. The final thing to mention is this large area here in the front of the unit. These are the drive bays. They are where the floppy and hard drives are mounted. A drive bay, which is 3 inches high, is called a full-height bay. It can hold 1 full-height drive or 2 half-height drives. Some drive bays are larger and can hold up to 3 half-height drives. That's it for the system unit. Next, we'll look at monitors. Another important part of the computer system is the monitor or display. We see some examples here. As you can see, they come in all shapes and sizes. In fact, there are many different types of monitors. This first monitor is called a monochrome monitor. It's called that because it can display only one color, usually green, but it may also be white or amber. In most cases, monochrome monitors cannot show graphics like pictures on the screen, only letters and numbers. However, with a special type of adapter, they can be used to show graphics in one color only. Another type of monitor is the color monitor, also known as RGB monitor, which stands for the three primary colors, red, green, and blue. Not all color monitors are the same. In fact, there are three basic types of color monitors. The most prevalent type of color monitor is called a Cga monitor. This stands for Color Graphics Adapter, which is really the name of the expansion card to which the monitor connects. However, because each monitor is designed to work with a particular card, the monitor is also known by those initials. A Cga monitor has several characteristics which define it. First, it has a maximum resolution of 640 dots, or pixels horizontally, and 200 pixels vertically. A pixel is one of the dots which make up the characters on the screen, as we see in this close-up. The Cga monitor can display a maximum of 16 colors, but only one color in the highest resolution graphics mode of operation. Second, it can display 80 characters across the screen and 25 rows of characters down the screen. A newer type of color display is the Ega monitor. Again, the monitor is named after the card to which it connects, the Enhanced Graphics Adapter. As you might guess, it offers improved performance over a Cga monitor. In fact, it can also display 640 pixels horizontally, but 350 pixels vertically. And it can show 4 colors at this resolution. In addition, it can display more characters across the screen and more rows vertically. Finally, there is a completely new type of monitor known as the VGA. VGA stands for Video Graphics Array. A VGA monitor can display 640 pixels by 480 pixels and 16 colors in high resolution. But the thing that makes VGA different from other monitors is that it is an analog monitor, not digital like the other monitors. This means that it can display a maximum of 256 colors, much more than the other monitors can. And analog monitors are less expensive, too. The final type of monitor we'll talk about is called a composite monitor. Technically, a composite monitor is a monochrome monitor. That is, it can only display one color. However, a composite monitor differs from a monochrome monitor in that it connects to a color graphics adapter and can display the same graphics as a Cga monitor, only not in color, of course. You can easily tell a composite monitor from a monochrome one by the connector. A composite monitor has an RCA jack, while a monochrome monitor uses a DB9 connector, so-called because there are 9 connection pins. One thing that is very important is that, in general, these monitors are not interchangeable. It is especially important that you never connect a monochrome monitor to anything other than a monochrome card, as this may damage the monitor and you may injure yourself as well. In the next section, I'll show you various keyboards. The final of the 3 main pieces of the typical PC is the keyboard, and here are some examples of different keyboards. As you can see, there are many keys with which you may not be familiar and several different layouts. Let's begin by going over some of the keys. You'll notice that there are several keys labeled F1 through F10 or F12. These are called function keys. They're used to perform different functions depending on the program that is running. For example, in one program, the F1 key may be used to save a file, while in another program, the F1 key may check the spelling of a word. You'll also notice a key labeled ESC. This is the escape key. This can again have different functions depending on the program you are running, but in general, it is used to quit what you are currently doing. This is why it's called the escape key, because it allows you to escape from what you're doing. Next, there are 3 different kinds of shift keys. They include the normal shift key, plus 2 others labeled ALT and CTRL for alternate and control. The shift key works exactly like on a typewriter. It allows you to enter capital letters plus the upper of the 2 symbols on keys which have to. To use it, you simply hold it down, press the key you wish to enter, then release it. The Alt and Control keys work just the same. Sometimes in a program, the instructions may require you to enter an Alt or Control key. To do this, simply hold down the Alt or Control and push the key. Then release the Alt or Control. There are three other keys which have a special function. They are labeled numlock for number lock, scroll lock, and PRTSC for print screen. First, the numlock key is used to turn on the numeric keypad, which we'll discuss in a minute, but it also serves another function. It can be used simultaneously with control to pause some functions of the computer, such as directory listings. Second, the scroll lock key can also be used with control to cancel some functions. On most keyboards, the front of the scroll lock key is labeled break. It also has a letter counterpart, which is Control C. When you hear someone mention breaking out of a program, it is this key combination, Control Scroll Lock, they're talking about. Now finally, there is the print screen key. You can print exactly what is on the screen by hitting Shift Print Screen. You should be aware, however, that this will cause your computer to lock up or stop working if you don't have a printer attached and ready to print. In addition, not all programs will allow you to do this at all times, and graphics screens require some special programming to be printed out properly. The right side of most keyboards is made up of what we call the numeric keypad. This is used to speed the entering of numbers into the computer. However, you'll notice that the keys have two different labels. This is because these keys can also be used to control the cursor, the small flashing block or underline on the screen. The left, right, up, and down arrows move the cursor in the respective direction, while the home, end, page up, and page down keys may do different things depending on the program you are running at the time. The function of the keys is switched with the numlock key we just talked about. Hitting numlock switches the function from numbers to cursor control and vice versa. Finally, the INS, or insert, and DEL, or delete, keys can also have different functions. You should check the manual that came with your program to find out what these and other keys do. One note, the delete key can be used in a very special way. When hit while holding down the Control and Alt keys, it reboots the computer. This has almost the same effect as turning off the power and then turning it on again. Your data is lost if you haven't saved it on a disk. This is called a warm boot, whereas turning the power off and back on again is called a cold boot. Incidentally, you should always wait 15 seconds after turning off the power before turning it on again. Keyboards come in many different layouts. This is a standard PC keyboard. It has the function keys on the left and the numeric keypad on the right. This is an AT keyboard. It's basically the same, but has some keys in different positions, such as the escape key. It also has status lights, which tell you when you have pushed the numlock, scroll lock, or caps lock keys. Finally, this is called an enhanced keyboard. It has the function keys along the top and has 12 of them. It has the numeric keypad as usual, but the cursor keys are replicated here so they can be used at the same time as the keypad. It also has status lights. Next, we'll take a look at some storage devices. Before, when we were looking at the system unit, you saw some large spaces called drive bays. As I said, this is where the different storage devices like hard and floppy disks are mounted. Let's talk about floppy disks for a minute. There are two different sizes of floppy disks used in PCs. The first and most prevalent size is this, a 5 1/4 inch floppy disk. This size of floppy disk also comes in two types. The most common type is called the double-sided, double-density diskette. This type of disk can hold up to 360 kilobytes of data. The other type of disk is called a high-density diskette and can hold up about 4 times as much data, 1.2 megabytes worth. Each type of diskette has its own disk drive. A high-density disk drive can create and use double-density disks, but not the reverse. A double-density drive cannot use high-density disks. You should be aware, though, that if you save data on a double-density disk using a high-density drive, this disk may or may not be usable again in a double-density drive. Floppy disks can be protected from being written on or having any files erased. This is called the Write Protect notch. If this notch is covered, the disk cannot be written on, only read. Small plastic adhesive back tabs come with the disks to cover up these notches. You should not use Scotch tape to cover the tabs because some disk drives tell if the tab is there or not by shining a light through the notch, and the Scotch tape is too transparent to be noticed. The other size of floppy disk is this, the 3.5-inch floppy. These disks even look different because they are made differently. 3.5-inch disks have a harder jacket and a sliding protective cover over the disk. These disks also come in two different types. The normal disk can store 720 kilobytes of data, while the high-density ones can hold 1.44 megabytes. This disk is popular with portable computers because of its size and is used in all the new IBM PS2 computers. These type of disks are write protected in a different manner. To write protect these disks, you must slide this little tab here so that this hole is exposed. The disk can only be written on or formatted if this little tab is shut. The floppy disks need floppy drives to read them. Floppy drives must be controlled by an expansion card. This card is called a floppy disk driver card or controller card. This card is usually installed in the expansion slot closest to the drive itself. Hard disks come in even more varieties. Hard disks can range in capacity from 5 megabytes to many hundreds of megabytes. Though a typical hard drive is 20 or 30 megabytes. They can be 5 1/4 inches in diameter or 3 1/2 inches, the same as floppy drives. In addition, hard drives can be mounted inside the system unit in the drive bays or on an expansion card, or be mounted outside the unit. Hard drives also need a driver card. In some instances, a single card may be used for both the floppy and hard drives. A hard drive which is mounted in the drive bay is called an internal drive. The drives usually slide into the bay from the front and are secured with screws on the side or bottom. Some 3.5-inch hard drives are mounted directly on their driver cards and installed right in an expansion slot. These types of drives are the easiest to install, but you should be aware that most of them limit the space in the expansion slot next to them, forcing you to use a short expansion card there. Other hard drives are mounted completely outside the system unit. These are called external hard drives. They still require you to install a driver card in one of your expansion slots, but they usually have their own power supply. A good thing if the power supply in your system unit is small or already loaded to capacity. External drives are not as popular because they take up more room on your desk and are usually more expensive. A different kind of hard drive has become popular lately. It's called a Bernoulli Box. It uses a disk similar to a floppy, but operates and has a capacity more like a hard disk. Its one big advantage is that the disks can be removed and exchanged like floppy disks, so your storage capacity is endless. The newest type of hard drive is called an optical drive. They do not store data magnetically, but rather optically with a laser beam. They're very similar to the home compact disc player and can store huge amounts of data. Their main drawback is that for the moment, they are very expensive. One thing you must know is that all floppy and hard disk drives have names which you must use when you use the computer. The drive name is one letter followed by a colon. The drive names start with the letter A, colon, for the first floppy disk drive in the system. If you have two floppy disk drives, the second one will be called B, colon. If not, the one drive is called both A colon and B colon. Hard drives start with the letter C colon and continue for as many drives as you have. You'll need to use these names often, so it is sometimes helpful to label the drives with a piece of tape until you become familiar with them. All types of disk drives, both hard and floppy, must be formatted before you can use them. Formatting a disk involves creating special areas on the disk called sectors and tracks. These are the places where DOS will be storing data on the disks. You might liken this process to putting labels on file folders before you put documents in them. It lets you know where things are. A sector is a pie-shaped piece of the disk, and a track is the collection of all the sectors around the disk. A cylinder is the set of all tracks that are all the same distance from the center of the disk. Now I've covered all the basics of a computer system. Next, we'll look at some accessories for your computer. At this point, having covered the basics of a complete system, I'd like to mention some popular accessories. First, most everyone will want to have some type of printer to use with their system. Some things you will want to inquire about when looking at printers are the quality of its type, the speed at which it prints, and how well it feeds paper. The speed of most printers is stated in how many characters per second it can print. An inexpensive printer may print at the rate of 80 characters per second, or 80 CPS. The fastest printers may print up to 700 CPS or more. There are 3 different types of printers used with PCs: daisy wheel, dot matrix, and laser printers. And daisy wheel printers, although currently not very popular, provide high quality at a low to moderate price. These printers print just like a typewriter does, forming each character by striking the paper with a metal or plastic die, shaped just like the character. They can print copies easily, but cannot print graphics. Now, dot matrix printers are the most popular printers. They can print fast and have good quality depending on the price. Dot matrix printers print by striking the paper with small pins which create dots on the paper. The dots are arranged to form characters. The more pins a printer has, the better the characters will look. And dot matrix printers can also print carbon copies and graphics. And these features, along with their low price, make dot matrix printers the printer of choice for many buyers. Now, finally, there are the laser printers. Laser printers can print very fast and with excellent quality. They can also print graphics. Laser printers work much like photocopy machines and print whole pages instead of single characters at a time. Most laser printers can print 8 pages per minute of normal text. Their only drawback is that they are more expensive than any of the other printer types. Although laser printers cannot make carbon copies, they are fast enough that in most cases you can print additional copies as separate pages after the first copy is done. Another device you may wish to purchase is a modem. The word modem is short for modulate, demodulate. It's used to enable your computer to communicate over a phone line with other computers. It enables you to transfer files back and forth and to run programs on other computers. Now, people have found many uses for modems. Some people use them to access airline reservation systems. Others dial up what we call electronic bulletin boards, or BBSs. These allow you to exchange information with other callers on many different subjects. Also, many libraries nationwide have computer systems which allow you to call up and perform book searches without having to go to the library itself. Something new to the world of PCs is the mouse. Here are 2 examples. What a mouse does is move the cursor. When you move the mouse up on the table, the cursor moves up on the screen. When you move it left, the cursor moves left, and so on. Using a mouse can help speed up some tasks because it is faster than using the keyboard to move the cursor. With so many people using hard disks these days, an important accessory for many to consider is a tape backup system. A tape backup system is used to copy the contents of the hard disk onto a tape cassette. Thus, if anything should happen to the hard disk or some files are accidentally erased, the information can be copied back from the tape. Something you may have heard mentioned before is the local area network, or LAN for short. Networks allow several computers to share devices like printers, hard disks, and tape backups, and to share information. They work by hooking all the computers together with special wires connected to network cards installed in the computer. Well, now that you've seen the most common component parts of a nice computer system, let's see how to choose the computer you need. How do you decide what type of computer and peripherals you need for what you want to do? Well, there are several factors you need to consider. These include processor type and speed, disk size, monitor type, printer type, and expansion slots. Notice that I didn't mention RAM in this list. This is because nowadays, if you have anything less than 640 kilobytes, you're seriously limiting the capacity of your computer. If you must, 512 kilobytes is an acceptable amount to start with. Processor type and speed are the most important things you should consider. The best processors you can get are the 8386, 8286, 8086, and the 8088 in order of most powerful to least powerful. Clock speeds for these processors range anywhere from 4.77 megahertz to 25 megahertz. If at all possible, you should try to get a machine with an 80 286 processor. These machines are normally called AT type machines. This will give you the best versatility in the future. Computers based on the 8088 or 8086 are called XT or PC type. As far as processor speed goes, you need to consider the type of application you are planning to run. If you'll be using a simple word processor or database, a lower speed will suffice. However, if you plan to use large spreadsheets or other number-intensive applications, you'll want a faster processor. You also want a fast processor if you will be doing a lot of graphics. The best processor at the moment is the 8386, running at 20 megahertz. Computers based on the 8386 are simply called 386 type machines. The next factor to decide on is the hard disk. It used to be that 10 megabytes was a large hard disk. Today, 20 or 30 megabytes is a standard size. And many computers come with hard disks of over 100 megabytes. The most disk-intensive applications are databases and graphics. If you plan on using one of these, you'll probably want a large hard disk. You'll also want a larger disk if you'll be using many different types of applications or using a single application a great deal. The speed of your hard disk should also be a factor. If you'll be using a computer based on the 8088 or 8086 processors, a hard disk with an access time of at least 60 milliseconds will give you good performance. For 8286 computers, hard disks of 30 milliseconds or less are preferable. And for 8386 computers, 20 milliseconds or less is the best. The type of monitor you'll need is your next consideration. The most expensive option would be a high-resolution color monitor. You would want this especially if you're going to be doing a lot of graphics, such as in desktop publishing system. But it also makes spreadsheets and word processing systems look very nice. However, a good monochrome monitor is perfectly acceptable for most word processing systems and even for spreadsheets, though you'll probably also want monochrome graphics for spreadsheets. The next you want to determine is the type of printer you'll need. You'll have three basic choices: an inexpensive dot matrix printer, a more expensive near letter quality dot matrix, or a laser printer, the best and most expensive of your choices. If you want the absolute best quality, which is essential for uses such as desktop publishing, you'll want a laser printer. If you need good quality but can't afford a laser printer, then you will probably want a near letter quality dot matrix printer. These can give you quality almost like a typewriter, but not quite. Finally, if all you want to do is print things out and don't really care about the quality, an inexpensive dot matrix printer is best. Now, these printers still give good quality, but no one is going to mistake it for typewritten text. Finally, you want to keep track of the number of expansion slots. Every computer comes with a certain fixed number of slots. The slots can be of three types: 8, 16, and 32-bit. An 8088 or 8086 computer will have only 8-bit slots, while an 8286 will have both 16 and 8-bit slots. Computers based on the 8386 processor will probably also have one or more 32-bit slots. Many of the options you add to your computer, such as a monitor or hard disk, take up an expansion slot with their interface card. Thus, you must be careful that you don't use up all your slots, or your computer's future expandability has just ended. And one way to do this is by using multifunction cards. These cards allow you to combine several different options in just one slot. The most important thing to do when selecting a computer is to completely and accurately define your needs first. Only by doing this can you hope to get a computer that will serve you well. Another tip is to decide which software you want to use and then get a computer which will run that software the best. Next, I'll show you how to get your computer up and running. Now that you're familiar with PCs, I'd like to show you how to set up your new PC, check it out, and get it working. After you've unpacked your computer, you'll want to save the boxes, at least temporarily, in case you need to return any defective parts or in case you must move the unit. You should check to see that all the pieces you ordered are included, and you should record all the serial numbers from the monitor, system unit, keyboard, printer, and any other accessories that have serial numbers. Now, once you have everything unpacked and checked, you need to determine a good place to set it up. Do not place your computer in direct sunlight or in a dusty area. You'll want an area with bright but not harsh lighting, and with easy access to electrical outlets. If at all possible, try not to use an electrical outlet that is on the same circuit as large appliances like your refrigerator or air conditioner. These devices draw large amounts of power and could disrupt the supply to your computer. In all cases, it is advisable to use an outlet strip that filters the power to your computer. These help protect your expensive equipment and make it easier to turn everything on and off at once. Now it's time to hook it all up. In most cases, you'll probably want to set the system unit on the tabletop, the monitor on top of it, and the keyboard out in front. This helps elevate the monitor for better vision and keeps the disk drives handy. If you have a printer, you'll have to place it within reach of the cable from the system unit. Now place the system unit on the table, place the printer near the system unit. Now you'll need to connect the printer to the system unit. If your printer is of the parallel type, the cable will have different ends. The end which connects to the printer will look like this. This is called a Centronics connector. Push it onto the connector on the printer and snap the two clips which hold the cable. The other end of the connector looks like this. It's commonly called a male DB25 because it has 25 pins sticking out of it. You'll need to locate the female connector on the back of the system unit to connect this to. If you find more than one, connect it to one or the other, and you can test it later. To connect it, you need to carefully push it onto the connector and tighten the two screws which secure it. If your printer is of the serial type, the ends of the cable may be of the same or different shapes. If the ends are the same, then it probably does not matter which end is connected where. Simply push the connectors on carefully and tighten the screws. If the ends are different, the end which is female, that is, it has holes instead of pins, is the one which connects to the computer. The connector may have 9 or 25 pins. Connect this to the male connector on the computer and tighten the screws. Connect the other end to the printer. Once the printer is connected, you need to connect the monitor. The connector on the system unit for a monochrome or color monitor will probably be a female 9-pin connector. Both ends of the cable will probably be the same. If so, it does not matter which end connects to which unit. If the ends are different, there will only be one possible way to connect the cable. If the monitor is composite, then the connector will look like a small hole. Connect the monitor cable to the connector on the computer and tighten the screws. Or push the connector into the hole if you have a composite monitor. If the monitor cable is not already connected to the monitor itself, connect the other end of the cable to the monitor. Now connect the keyboard to the system unit. The connector for the keyboard is a round female plug to which only the keyboard will connect. In most cases, it is in the middle rear of the system unit, but it may also be on the front. Finally, you need to connect the power cables. Each unit, except for the keyboard, should either have a power cable built into it or have a plug into which a power cable will connect. Plug each unit into the outlet, making sure that the power switches are in the off position before you do so. Before you power up the system, you need to prepare to boot the system. To boot or turn on the system, you'll need the DOS diskette. This should be located in the back of the DOS manual. You don't want the disk labeled Supplementary Programs or Disk 2, rather you want Disk 1. Now place this diskette into drive A, usually the one on top or to the left if there are two. Now turn the system on by first turning on the system unit, then the monitor, and the printer. After a short wait, you should see a statement like this one come up on the screen. If nothing appears on the screen, try adjusting the brightness and contrast controls first. If this is still unsuccessful, contact your dealer for assistance. The computer will then prompt you to enter the date and time. Do this as I am doing here. When you have entered both, you will see an A prompt displayed on the left side of the screen. This is called the A prompt or DOS prompt, and it is indicating that you are currently working with the A disk drive. The letter will change as you work with different drives. At the DOS prompt, you enter commands for DOS to carry out. The first command we will perform is the one which will back up the 2 DOS disks. You will need to have 2 blank floppy disks before you start this procedure. If you do not have these, stop the tape now and restart it when you have the diskettes. To make backup copies of these disks, we're going to use the DOS command called disk copy. Type disk copy A : space B : hit the return key. This command will copy the disk in drive A to the disk in drive B. However, the process is a little different depending on whether you have 1 floppy drive or 2. If you have 2 disk drives, you will now see a message which asks you to place the original disk in drive A and the blank disk in drive B. Place the DOS disk in drive A, place the blank disk in drive B. When this is done, hit the return key to start the process. You will see the drive lights come on several times, and then you will be asked if you wish to copy another disk. Since we also want to copy the second DOS disk, type Y for yes. You will then be asked to place the disks in again. Place the second DOS disk in drive A, place a blank disk in drive B. Hit the return key. After the second disk is copied, type N for no when asked if you want to copy another disk, and you will see the A prompt again. If you have only 1 floppy disk, the process is slightly different. The computer will first ask you to place the disk you wish to copy in drive A. Since the disk we wish to copy is already in drive A, simply hit the return key. After part or all of the disk is read, depending on how much memory your computer has, the computer will ask you to insert the target disk in drive A. Now, since you have only 1 disk drive, remove the original DOS disk and put in a blank disk. Then hit the return key. Depending on how much memory your computer has, the copy may not yet be complete. If the disk was not copied completely on the first pass, you will have to reinsert the original disk when prompted to do so, and again strike return. You will see the drive light flash some more, then you'll be asked to insert the target disk again and to strike return. Then the process will be completed. Again, type Y for yes to the copy another disk question, and follow the same procedure with the second DOS disk and another blank disk. When both disks have been copied, you should run another program which checks the integrity of the copies. This program is called disk comp and stands for disk compare. To run this program, type disk comp A : space B : and hit the return key. You will be asked to place the original disk in drive A and the copy in drive B. If you have only 1 disk drive, you will have to switch disks as you did when making the copy. Do this and then hit the return key to start the compare process. If when finished the program says there are problems with the copy, repeat the copy process above using the same disks and try the compare program again. If you still get errors, use another blank disk to make another copy and throw the bad disk away. If you still get errors, you probably need to have the disk drives looked at by the dealer. If the disks are identical, you'll be told the compare was okay. You then have the option of comparing another disk. Repeat this process for the second disk. At this point, you have made backup copies of both the original DOS diskettes. You should not use the original disks again except to make more backup copies if need be. You should always use the backup disks instead. In addition, put Write Protect tabs on these diskettes so that you don't accidentally erase any files or format the disks accidentally. If you don't have a hard disk, you don't need to watch the next section. Although you may find it useful at a later time, you can skip to the section which covers DOS. For those of you who have hard disks, we will now proceed to set them up. You should be aware that many dealers set up the hard disk before they deliver the computer to you. If this is the case with your machine, you may not want to follow this procedure. You may wish instead to just follow along without performing the steps to get an idea of what is going on. In addition, due to the wide variety of hard disks available, there are many different ways to set up different hard disks. The following procedure is the most common way. You should check to see if any special instructions came with your hard drive and follow those where they differ from the following. The first thing you must do to the hard disk is run the DOS program fdisk. This program partitions the hard disk. A partition is a section of the disk that can act as a disk by itself. That is, one hard disk can act as 2, 3, or more separate disks by being partitioned as many times. These partitions act as logical drives. That is, each one has a separate drive name, C:, D:, E:, and so on. Logical drives are different than physical drives in that they do not exist as separate physical units. Logical drives are only separate in that they have different names. You may or may not want to set up more than one partition on your hard disk. If your hard disk is more than 32 megabytes in size, you will have to set up more than one partition unless your disk came with a special program which specifically states that you don't have to. The reason you must break up a disk larger than 32 megabytes is because that is the limit that DOS can use for any one disk. These special programs I mentioned make a change to DOS which allows you to use a larger drive. If you have one of these special programs, you should follow the instructions which came with it instead of the procedure I will describe here. If your hard disk is less than 32 megabytes in size, it is not necessary to make more than one partition unless you know that the software you will be using requires that. In most cases, it will not. Whatever the case, you will still need to run the fdisk program. If you have MS-DOS, put the first DOS diskette in the A drive. For PC-DOS, use the second DOS disk. Then at the A prompt, type fdisk. Hit the return key. You'll then see a menu which has several choices on it. Create DOS partition, change active partition, delete DOS partition, display partition information. You can check to see if your hard disk has already been partitioned by picking option number 4. If you see a line which says no partitions defined, then your disk has not been partitioned yet. In other cases, you will see a line or lines describing each partition, such as this shows that you have one partition that is active or bootable, which is shown by the A under status. In addition, it is the primary DOS partition and is 732 cylinders in size. The partition begins on track 0 and continues to track 731. If you see a line similar to this, you need not continue with this procedure. If your disk has not been partitioned, return to the menu by hitting the Escape key. Now, pick the option to set up a partition, number 1. Now, pick number 1 again to create a primary DOS partition. You will now be asked if you wish to use the whole disk for the partition. If you are going to make only one partition, then you need answer yes. If you are going to set up more partitions, you should say no. If you say no, you will have to enter the beginning and ending track numbers for each partition. You should probably discuss this with your dealer, as there are many options you can choose in setting up more than one partition. We'll be picking the option to set up the entire disk for DOS, so we'll type Y for yes. For PC-DOS users, take out the second DOS disk and put the first DOS disk back into drive A, then hit the return key. You'll notice that after a few moments the system will reboot. At this time, the hard disk must be formatted. Again, for PC-DOS users, remove the first DOS disk and put the second one in. Then strike Enter twice and type format C:/S/V and hit the return key. This is the command to format the hard disk. Since some DOS files are to be placed on the hard disk itself during the format process, you must now remove the second DOS disk and put the first one back in and hit the Enter key. You'll see a message which informs you that all the information on the disk will be erased if you proceed. Since you have no information on the disk yet, type Y for yes to the question. This message is a safety measure to help prevent you from accidentally formatting the hard disk when you didn't intend to. You will now see a status line come up. This line tells you how far along the format process is. You'll see the numbers increase as the disk is formatted. The format process will usually take just a few minutes to complete. When it's finished, you'll see the message Format Complete, System Transferred. This means that the formatting is finished and that the DOS system files have been placed on the hard drive. These are the essential files that must be present for the disk to operate. Now that the hard disk has been partitioned and formatted, you need to copy the rest of the DOS programs onto it so that you won't have to use the floppy disk should you need to run a DOS program. To do this, you need to make a subdirectory to put the programs in. We'll talk more about subdirectories in the next section, but for now, you only need to follow these directions. At the A prompt, type C:, and hit the return key. You'll now see the prompt change to C. This means you are now working with the C drive, the hard disk. Now type MD \DOS and hit the return key. This makes a directory called DOS where the DOS programs will be copied to. Now you need to copy the programs themselves. With the first DOS disk still in the A drive, type copy A:\\, period, asterisk, space, C:, \DOS/V, and hit the return key. This tells DOS to copy all the files from the disk in drive A to the DOS directory on drive C. You'll see the disk lights flash and the names of the programs will scroll down the screen as they're copied. When the copy is completed, you'll see a message telling how many files were copied, and the C prompt will return. Now replace the DOS disk in drive A with the second DOS disk and strike the F3 key. This will duplicate the last command you typed to the DOS prompt. You'll notice that an appendix in your manual describes the functions of this and other helpful keystrokes for DOS. Hit the return key. This will copy all of the files on this disk onto the hard drive. At this point, you have partitioned the hard disk, formatted it, and copied the DOS programs onto it. If your computer came with any diskettes, such as one containing some utility programs, you'll probably want to copy it onto the hard disk also. If it did not come with instructions as to how to do this, you can follow the above copy instructions, replacing DOS in the commands with something like utility or another name of your choosing for the directory. There is one more thing I'd like to show you how to do in this chapter. DOS has a special function which allows you to have certain commands executed each time you boot your computer. These commands are stored in a special file called autoexec.bat, which stands for Automatically Executed Batch File. The batch file we will create will let you see and set the date and time each time you boot the computer, tell DOS where all of its files are stored, and set the DOS prompt to display the current directory. To do this, at the C prompt, type copy autoexec period bat. Hit the return key. Type date. Hit the return key. Type time. Hit the return key. Type path C:\, C:\, DOS, C:, utility. And hit the return key. Type prompt $P$G. Hit the return key. Hit the F6 key. Hit the return key. You can leave out the C:\utility if you didn't copy a utility disk. After you type this in, you'll see the message "one file copied." This created the autoexec batch file on your hard disk. Now we'll create a config file. A config file is like an autoexec file in that it contains DOS commands which will be executed automatically on boot up, but differs in the type of commands it contains. Commands in a config file are specifically designed to be used as such. They change the ways DOS operates all the time, rather than just when they are executed. Enter the following at the C prompt. Type copy config period sys. Hit the return key. Type files equals 30. Hit the return key. Type buffers equals 30. Hit the F6 key and hit the return key. This will set up your computer each time you boot up to operate more efficiently. The first line tells DOS that as many as 30 files can be opened at one time, which is needed for database programs. The second line sets up buffers, temporary storage areas, in memory. These hold the most recent information you've read from the disk. In that way, if that information is needed again, it is already available in memory and can be retrieved much more quickly. Now it's time to test everything we've done. First, remove the DOS disk from the disk drive. Reboot the computer by typing Control-Alt-Delete. If you've done everything correctly after several seconds, you should see something like this. If the date is incorrect, type in the correct date and hit return. Then the time will be displayed. Again, if incorrect, type in the correct time and hit return. Now you will see the path command displayed. Finally, the C prompt will appear. This means that your format was successful. Now it's time for you to install the software programs that you'll be using on your computer. Read the instructions for each package you install carefully before you begin. Oftentimes the installation procedure is very different depending on what type of computer system you have and how you'll be using the program. Something you should always do is make backup disks for each of the disks your programs come on, just like we did for the 2 DOS disks. Most installation procedures will have you do this as you install the program. Now you're ready to begin learning about DOS, the Disk Operating System. Now that you have your computer up and running and have DOS installed, it's time to learn how DOS operates. DOS stands for Disk Operating System. Sometimes you may hear people refer to it simply as the operating system or the system. DOS is a collection of programs that collectively run your computer. These programs act as the base for your application programs to work on. What DOS does is remove the idiosyncrasies of the hardware from the software. For example, without DOS, when an application program wanted to save a file, it would have to know what type of disk drives were available, how they were formatted, find the correct sectors, write the data, check the data, update the directory, and so on. But with DOS, the program only need ask DOS to save a file with such and such name and send it the information. DOS takes care of the rest. This simplifies the programming necessary for every software package and makes the computer easier to use. DOS was originally written by the Microsoft Corporation. However, since the function of DOS is to take care of the differences between different computers, most large manufacturers have their own version, which they have modified for their systems. IBM's version of DOS is known as PC-DOS, while Microsoft calls its version MS-DOS. DOS has evolved over the years. The original DOS was version 1.0 as compared to the current version of 3.3. Each version can run programs of every version below it. DOS 2.1, for example, can run programs designed for DOS 1.0, but not for DOS 3.3 in most cases. You also cannot use the individual DOS programs from different versions. A mistake that many people make is to update the DOS programs in one part of their disk, but not in another. Then, when they try to use the programs from that other part, they will receive an incorrect DOS version message. There are 3 very special DOS files. Their names are, depending on whether you have MS-DOS or PC-DOS, IOSys, MS-DOS-sys, and Command-COM, or IBM BIO-COM, IBM DOS-COM, and Command-COM. These are sometimes collectively known as the system files. They're the minimum requirement you must have to run DOS. However, you will never see the first 2 of these files. The reason is that they are hidden files. This means that they won't show up on a directory listing. They're hidden from the user so that you don't try to copy or delete them. This is because these files must be in a special place on the disk called the boot record. The only way to put these files on the disk properly is to format it with a system option that I will describe later, or to use the sys command on the disk. Well, that is very basically what DOS does. Most of the remainder of this lesson covers DOS in greater detail, but in the next chapter, I'll briefly explain files and directories. There are some things you must know about how DOS stores program and data files. Every file that is stored on your hard or floppy disk has a name. The file's name is made up of two parts, the file name and the extension. The name is in the form, file name dot extension. That is, the file name comes first, then a period, then the extension. The file name is made up of as many as 8 characters. However, there are some restrictions as to how you can name a file. You're allowed to use all the letters in the alphabet, the numbers 0 through 9, and these special characters. You may not use blank spaces anywhere in the name. In this case, as well as any other time you're using DOS, you may use either upper or lower case, as it doesn't matter to DOS. You should be aware that since DOS does not care about case, the file name Joe letter in all caps is the same as Joe letter in all lowercase. They will not be seen as separate files. In addition to the file name, you may also add an extension to the file's name. The extension may be up to 3 characters long, and you can use the same characters as for the file name. In general, you should try to name your files according to what they are. In other words, try to make the name a shortened phrase for what the file is. For example, use Joe letter period doc for a letter to a friend named Joe. Notice that I use the underscore as a substitute for a blank space. Many new users make the mistake of naming files with consecutive numbers like letter 1, letter 2, letter 3, etc., only to find out later that they have no idea what those files are. You should remember, unless you erase a file, it will be on your disk pretty much forever, so use a name you can associate with later. You'll notice that in the example above, I used doc as the extension. This stands for document and is a common extension used by many people. There are some very common and some special extensions that you should be aware of. Here's a short list. In particular, note the 3 special extensions BAT, COM, and EXE. These are the only extensions you will ever find on a program that you can run. In other words, these 3 are special extensions that DOS uses to signify programs, and you should never use one of them as the extension for a data file. There will be times when you want to perform a command on a group of files at one time. The way to do this is with wildcards. Wildcards are just what they sound like. In poker, a wildcard can act like any other card. The same happens with DOS. A wildcard can be used to stand for any character. The 2 DOS wildcards are the question mark and the asterisk. The question mark can be used to stand for any single character. Here's an example. This command, called Directory, will list all the files that have file names starting with letter, followed by any single character, and ending with the extension doc. For example, the files letter 1 period doc, letter A period doc, and letter # period doc would be listed. However, the files letter 12 period doc or letter 1 period txt would not be listed because 12 is 2 characters, not 1, and txt does not match with the extension we specified. The other wildcard is the asterisk. The asterisk differs from the question mark in that it can stand for any number of characters. For example, this will give us a list of all the files which start with L and have a doc extension. All the files letter 12 period doc, letter A period doc, laugh period doc, and LA period doc would be listed in the directory. Remember when you copied the DOS disks onto the hard disk a while ago, you typed A:** period asterisk? This told DOS you wanted to copy all file names with all extensions from drive A. so you've already used a wildcard. When using DOS, there's a big difference between program files and data files. You see, a program is a very special type of file. When you run a program by typing in its name at the DOS prompt, DOS loads the data in the program file into memory and transfers control of the computer to the program. This means that the data in a program file is very special, and this is why program files must be treated and distinguished differently than regular data files. A data file, on the other hand, never controls the computer. Data files are used by programs. As such, it is not uncommon for a group of data files to belong to the same program. That is to say, the data files will only work with that program, since that particular program created them in a way which perhaps other programs may not be able to recognize. For example, a data file containing a worksheet that you stored on the disk when you were using a particular spreadsheet program may not be readable by another program, even another spreadsheet program. This may seem strange because all you see on the screen are letters and numbers. However, when the program stored the data on the disk, it stored it in a special way, in a code, which makes that program work better and more efficiently. But another program may use a different type of code, so the data files cannot be interchanged. The people who write programs recognize this problem and oftentimes account for it. Some programs are written with the ability to use data from other programs either directly or by translating the data into a form they can recognize. Since there is a need to separate programs and data which belong to each other from those that don't, DOS has special functions which make this easy to do. You have the option of setting up what we call a directory structure or directory tree. The best way to explain what the directory structure is might be to compare it to a filing cabinet. Just like you have files stored in a filing cabinet, you can have files stored on your disk. In a filing cabinet, you can store files that belong together in a folder. In addition, you can store all the folders that belong together in one of the file drawers in the cabinet. The same ideas apply to your disks. You see, a folder on your hard disk is called a subdirectory, and a file drawer is like each disk drive. All your drives together make up the filing cabinet. Now, when you use a filing cabinet, you go through a certain process. Say you want to get the file which has your tax returns for 1980. Well, first you might go to the top drawer where you keep your finances, then to the tax return folder, and finally to the file for 1980. You have a specific order to describe the path you took to get to the file you needed. Well, the same applies to your computer. To have DOS find the file on your computer, you also have to get it a path to follow. In a similar example, you would first go to the C drive, where you keep your finances, then to the subdirectory, where your tax returns are stored, and then to retrieve the file for 1980. The only difference is that on the computer, you must exactly specify the path to follow to get to the file. The path takes a special form that looks like this. The first part of the path is the drive name, always with a colon. This is followed by the name or names of the subdirectories, and finally, the file's name. The reason we call this file structure a directory tree is because that's what it looks like. Here's what a typical directory tree might look like. The upper left-hand side is the root of the tree. The right-hand side is the branches. All the names you see are all the subdirectories except for one. Batch is a subdirectory, Graphs is a subdirectory of the subdirectory Lotus, and 1987 is a subdirectory of Taxes, which is another subdirectory of Lotus. However, there's one directory whose name is not listed here and which you will not see on any other directory listing. That directory is the root directory. It is depicted in this diagram by the first line in the upper left corner. In a path name, it's represented by the first backslash. It's always simply called the root directory. Now let's figure out the paths to some of these subdirectories. To get to a file in the 1987 subdirectory, the path is C:/Lotus/taxes/1987/file name. On the other hand, to get to a file in the root directory, you only need, say, C:/file name. The DOS directory structure is very useful, as you can see, for separating areas of your disks to keep your files and programs organized. You will need to remember how this directory structure looks and how to specify path names, because you must frequently use them to tell DOS how to find files and programs. DOS will naturally search the directory you are currently working in for files. However, in addition, you can tell DOS to search several different paths automatically when looking for files and programs. You'll see how to do this in the DOS commands chapter. DOS would be useful if all it did was to act as an interface between the programs you run and the computer itself. But it's much more than that. As you saw when we copied the DOS diskettes onto the hard drive, DOS comes with many more files than just the 3 you need to run it. What are all these extra files? Well, they're the files which make up some of the DOS commands. A DOS command is a function of DOS, like copying a disk, getting a directory listing, or setting the date and time. It's learning what these commands are and how they work that will make you an expert at using your computer. Using DOS commands is just like running any other program. All you need to do is type the name of the command at the DOS prompt and hit the return key. However, there are 2 things you must be aware of. First, there are 2 types of commands, external and internal. Second, every command has its own particular syntax or format you must follow when you use the command. There are 2 types of DOS commands, internal and external. Internal commands are those commands which are part of the file command.com, which we loaded into the root directory of the hard disk when we formatted it, and which is present on all floppy disks that can be used to boot the computer. Internal commands can be used anytime you have the DOS prompt on the screen and do not need any other files to work. The reason that they are set up this way is out of necessity. For example, say that one copy command was not an internal command. In order to make a copy, you would have to have the copy program file on your disk. But how would you get it on your disk if it wasn't already there? If it wasn't already on the disk, you wouldn't be able to copy it on, you see? Internal commands are set up so that you can use them as soon as you boot up the computer with DOS. I'll point out as we proceed some of the commands which are internal. External commands, on the other hand, need a program file to run. In fact, they are just like any other program you might run in that you must have the file present for it to work. External commands are sort of the optional parts of DOS, the parts that aren't necessary, but you might want to use in some cases. They were made external to save space. When you want to make a floppy disk that has DOS on it, you want to be able to take up the minimum amount of space for DOS and leave the rest for the programs and data files that will be put on the disk. The essential DOS commands are made part of command.com so that they will always be present, and the optional ones are made into separate files so you can add them as desired. So in order to run external commands, you must have the program file available either in the directory you are working in or specified in the path you have set up. Now, let's take a look at command syntax. Every time you use a command, or any other program for that matter, you must use a specified syntax. That is, you must enter the command name as well as any other optional features in a certain way for the command to work properly. Here's an example of using the copy command. A typical copy command you could execute might look like this. However, if you were to look in the DOS manual for the proper way to type in this command, this is not what you will see. Instead, you will see a syntax notation like this. Looks a little bit confusing, doesn't it? Well, it's very simple when you break it down. This is the way the DOS commands are listed in the manual, so that all the options available to you when you use a command are readily apparent. Now let's look at this syntax notation more closely and see how an actual command relates to it. The first part of the syntax notation is the command name, copy. This is followed by several things in brackets. Brackets are special characters when used in a syntax notation. When you see brackets, they mean that what is in them is optional. However, you don't actually type the brackets with the rest of the command. Next, the D: stands for a drive name and is followed by a path name if it is needed. The slashes followed by a character are called the switches. They make the command do different things depending on which switches you use. As you can see, they are optional because they are shown in brackets. You'll learn how to use switches in the DOS part of the lesson. In addition to the brackets, there are other characters which are special when used in the syntax for a command. If you see an ellipsis, 3 periods in a row, in the syntax, this means that you can repeat an item as many times as you want. Should you see a bar, this means that you can type in one of the 2 items on either side of the bar, but not both. As with the bracket, you don't actually type in these characters as part of the command. So how does the syntax relate to the command we showed earlier? Well, first off, of course, the name of the command copy is present in both. Second, we left out the first 2 optional switches because they weren't needed for the function we wanted. Then the drive name A:, was used, but without a path. The file name is present because it is required, as you can tell, since it is not in brackets. It also has the optional extension with it. The next 2 switches were also left out, like the first ones were. Then we used a drive name C:, a path \word_proc, and a file name letters, but this time without an extension. Finally, we left out the final optional switches, so you can see that the command follows directly from the syntax. The end result would be to copy the file joeletter.doc from the disk in drive A to the word proc subdirectory on the C drive, and to call them the new file letters. You must, however, be careful when you use commands for the first time that you get the syntax correct. Next, we're going to go over some of the DOS commands you will use regularly. What follows is a summary of some of the most important DOS commands. Some of these commands you may use regularly and others you may use only once or twice. However, they are important to know just the same. This chapter will cover the most common DOS commands, while the more advanced commands will be covered in the next chapter. Each command will be dealt with separately, but in some cases commands can be used together with another command to perform an additional function. When this is the case, it will be clearly described. In the following command syntax descriptions, everything you see in capital letters is required when you type in the command. Things in brackets are optional. Remember not to put brackets in the actual command. In the examples, a common command will be shown followed by any response from DOS under it. Then a short description of the command will be given. I'm going to run this lesson from the hard disk or drive C. If you don't have a drive C, simply use a drive you do have whenever I refer to drive C. During examples, I will frequently change the drive I'm currently using, but I'll usually return to drive C. And make sure you have a C prompt on your screen now. If you don't, type C:, and strike Enter. This should move you to the C prompt. During the following examples, I'm going to be using various file names and directories which are on my computer. Obviously, you need to use the file names and directories you have set up on your own system. The data disk that came with this lesson contains all the files that will be used in this lesson. You can use this disk in drive A on your computer. Most importantly, you should make a backup of this data disk, just like I showed you when backing up the DOS disks. This way, when we delete files during the lesson, you will still have a copy of every file on your backup disk. If you want to perform the exact examples I'm going to demonstrate, you will need to create the necessary directories on your hard disk. Then copy the necessary files into the directories from the data disk. You will learn how to make directories and copies in just a moment. It may be helpful if you follow along in your manual during these DOS commands so you can see the syntax for each command. In this chapter, I'm going to cover the most basic and/or most commonly used DOS commands. In the next chapter, I will show you the more advanced commands or less used commands. The commands will be covered in alphabetical order in both chapters. The first command I want to talk about is the CLS, or clear screen. Now, this is a very simple command with a simple function. All it does is clear the screen and reposition the cursor at the first line. This is useful in batch files for getting a blank screen before a menu or directory listing is displayed. Type CLS, strike Enter, and this clears the screen. I'll use this command from now on to clear the screen between each example. You can do the same if you wish. To avoid redundancy, I'm not going to tell you to clear the screen each time. Simply clear the screen after each example if you desire. The next command is the copy command. No matter which syntax you use for this command, the first file name you specify is the source file, the one that will be copied. The second file name is the target file, the one which will become the copy. There are three switches you can use with the copy command. The /v switch is used to verify the copy. And normally when DOS makes a copy, it does not check to see if the copy is the same as the original. If something goes wrong during the process, and it can occasionally, then the copy may not be exact. In order to have DOS verify the copy, you must use the /v parameter. Alternately, you may execute the command verify on each time you use the computer, such as in your autoexec.bat file. In this case, you will not need to use the /v since DOS will automatically verify all copies. The only disadvantage is that copies will take slightly longer when you use it. However, its use is recommended unless you are really in a hurry. The function of the /a switch differs depending on whether you use it after the source or the target file. When used after the source, it causes the copy process to continue until an end-of-file character is encountered in the file. This means that the file is treated as an ASCII data file, a text file, which normally has an end-of-file only at the end. The end-of-file character is not copied. When used with a target file, this causes an end-of-file character to be added to the end of the file. The /b switch also has two different functions. When used with the source file, the copy process is continued based on the size of the file stored in the directory. When used with the target file, the end-of-file character is not added to the file. The default values, if you do not specify any switches, are to use /a when files are being linked together, normally ASCII files, and to use /b in all other cases. Now these two switches, the A and B, are rarely needed or used, so you need not worry about memorizing their functions. You may use wildcards to copy more than one file at a time. Now for some examples. Type copy A:***, */v, and strike enter. Now this copies all the files in the current directory of the A drive to the current drive and directory you are using. All the files will have the same names they had in the A drive. Type copy *doc A:*/ v and strike enter. This copies all the files with the doc extension from the current directory to the A drive. Again, all files keep their names. Type copy A:**, C:, \lotus/v and strike enter. Now this copies all the files on the current directory of the A drive to the Lotus directory on the C drive with the same names. This, of course, will only work if you have a C drive. This next example is going to require a letters directory on a disk in drive A. Put the data disk in drive A and type mda:\letters and strike enter. You also need to make sure you have the file letterjohn.doc in the current directory of the C drive. This file can be copied from the data disk using the copy commands you just learned. Type copy C:, letter, John, doc, space, A:\, letters, letter, Jack, doc/v and strike enter. This copies the file letterjohn.doc on the C drive to the letters subdirectory on the A drive and gives the file a new name, letterjack.doc. You see how easy it is to create the necessary directories before performing an example. Type copy letter John, doc plus letter end period doc and strike enter. This adds the text from the file lettern.doc to the end of the file letterjohn.doc and keeps the file name letterjohn.doc. Type copy letter John period doc plus L trend period doc space letter new period doc and strike enter. This does the same thing as the previous example, but creates a new file called letternew.doc instead of keeping the old file name. Finally, you can use copy to move data between system devices. The most important device is con, which is the keyboard. You saw how to use this earlier when we created the autoexec.bat file. This command copies what you type on the keyboard, con, to the file autoexec.bat. You can also print a file with the copy command by using the printer's device name. This name will be LPT1 for a printer connected to the first parallel port, or COM1 for a printer connected to the first serial port. You can change the name 1 to 2 or 3 if your printer is not connected to the first port. To print out your autoexec.bat file, you should type copy autoexec period bat LPT1 colon and strike enter. You can use this same command form to copy any file to the printer. Because the copy command is so complex, there are many other ways to use it which we can't cover here. Please see your DOS manual for a complete description. Our next command is the date command. This command is used to either set or display the date held in the internal clock. If you type in date only, the current date will be displayed and you'll be prompted to enter a new date if you wish. On the other hand, you may enter the date directly as shown in the syntax without displaying the current date. DOS will automatically ask you for the date and time when you boot up if you do not use an autoexec.bat file. If you do, you may want to put the date command in your autoexec.bat file so that you can check it. Now, type date, strike enter, and you'll see something like this. Current date is Sunday, 06/05/1988. Enter new date, colon. This displays the current date and prompts you to enter a new date if you wish. If not, just strike enter. Now, type date 06/08/88 and strike enter. This sets the date to June 8, 1988 in one step without displaying the current date. Our next command is the delete command, which is abbreviated DEL. Now, this command deletes or erases a file or files from a disk. You can use wildcards to delete groups of files. If you do not use a file name in the command, all the files from the specified drive and path or the current drive and path will be deleted. Before a command which would delete all files is executed, a message will inform you that this will be done, and you will have a chance to stop the command. Now, once a file is deleted, it cannot be retrieved again unless you have access to certain programs designed to do this, and then only under special conditions. Therefore, be very careful what files you do delete. Now, type delete John, period, letter, and strike enter. This will delete the file John, period, letter if it exists in the current directory. Type delete A, colon, asterisk, period, letter, and strike enter. This will delete all files with the extension letter on the disk in the drive. Type delete asterisk, period, asterisk. Strike enter. This will delete all the files on the current drive and directory, but only if you answer yes to the question warning you that this is going to be done. Type N for no. Type delete C, colon, backslash, XL, and strike enter. This will delete all the files in the XL directory on drive C, again only if you have a C drive with an XL directory. In this section, we'll be talking about 4 new commands, beginning with the directory, abbreviated dir. Now, this command is used to get a listing of the files in a directory. You may ask for only a list of certain files by using the file name parameter. If you can't specify a drive and/or directory in the command, you will get a listing of the current drive and directory. Now, sometimes a directory is too large to fit on the computer screen at one time. You can cause the screen to pause when it gets full by using the /P switch. Then strike any key to continue the directory listing, one screen full at a time. If you don't need any information other than the file names, you can cause the display to change to another format by using the /W switch. In this wide mode, file names will be displayed 5 columns across on the screen so that more are viewable at one time. Let's practice this. Type directory asterisk period doc /P/W and strike enter. This displays a list of all the files with the doc extension on the current drive and directory. The list is wide and pauses if the screen fills up. Type directory A:, and strike enter. This displays a list of all the files in the current directory of the A drive. The display is in the standard form and will not pause. There must be a disk in drive A, or you'll receive an error message. And here's what a normal directory listing might look like. The above listing has the following information: file name and extension, size in bytes, date, last saved, and time, last saved. Our next command is the disk copy command. This command gives you a quick way to copy a whole disk all at once. You have no option of copying only certain files. The first drive you specify in the command is the source disk, the one that will be copied. The second is the target disk, the one that will become the copy. You may use the same drive for both the source and target disks, in which case you will be asked to switch the diskettes when required. This will be necessary if you only have one disk drive. This command does not work for hard drives. The target disk will have the same exact files as the source drive. The target disk does not even have to be formatted before it is used. The disk will be formatted as the disks are copied. Using the /1 switch will copy only one side of the diskette. This should only be used if you are specifically instructed to do so by a manual. And be aware that some disks are copy protected, especially games. Copy protection is a measure taken by the manufacturer of the software product you are trying to make a copy of to keep you from making copies and giving them to your friends. A disk which is copy protected cannot be copied using disk copy. You will probably receive error messages during the process. Now, since DOS does not check the copy it makes of the disk during disk copy, it is often a good idea to run the associated command discomp after using disk copy, as we did earlier when we copied the DOS disks. After the process is complete, you will be asked if you wish to make another copy of the same or a different disk. Now, type disk copy A:, B:, then strike enter. You'll then be prompted to insert the source disk, the disk you're making a copy of, in drive A, and the target disk, the disk that is going to become the copy, in drive B. Now let's copy the data disk that came with this package. Put the data disk in drive A and a blank disk in drive B. Then strike any key. This will copy the disk in drive A onto the disk in drive B. When the copy is complete, you'll be prompted, copy another diskette, yes or no. If you want to make another copy, type Y for yes and repeat the same steps you just completed. If not, type N for no. If you only have one disk drive, the process is essentially the same, but you must follow the directions the computer displays during the process. Type disk copy A:, and strike enter. You'll be prompted to switch the target and source disks in disk drive A as needed to make the copy. Again, you'll be asked if you want to make another copy when you're done. The next command is the format command. Now, this is one of the most important DOS commands. Not only does it prepare every disk you use to work with DOS, but it also checks those disks for bad sectors. It can also be used to completely erase a whole disk, since the formatting process does this as part of its operation. There are many switches, as you can see, for this command. If you do not use any switches, the disk you are formatting will be completely erased. As a result, the space on the disk will be available entirely for data storage. The format will prepare the disk using the default settings of the drive being used. Each switch slightly modifies this process. The most important is the /S. When you use the /S switch, the disk you are formatting will have the first part set aside for the three essential DOS files: IBM bio .com, IBM DOS .com, and command .com. Now, these files will also be copied onto the disk during the format process. The purpose of this switch is to create a disk which can be used to boot the computer, called a bootable disk. This means, however, that a small fraction of the disk space is not available for use by you, since it is taken up by DOS. The /1 switch is used to format only one side of a diskette. This command can only be used with floppy disks and is usually needed only if a disk is to be used with DOS version 1.0. The /8 switch is also used for diskettes that will be run with an old DOS. It causes the format program to place only 8 sectors per track instead of the default of 9. Again, it can only be used with diskettes. The /V switch allows you to place a volume label on the disk you are formatting. The volume label is displayed when you use the directory or check disk and is useful for keeping track of disks. You cannot, however, use this with the /8 switch. The /B switch is another older DOS command. It formats a disk with 8 sectors per track and leaves space for the DOS files, but does not copy the DOS files onto the disk. The DOS files can later be put on the disk with the sys command. You will need to use the /4 switch if you want to format a normal double-density diskette in a high-density disk drive. The 4 is a reminder that 360 kilobytes is about 1/4 of the 1.2 megabytes. The /N and /T switches are used with special types of disk drives. If you need them, most likely you will be told so in the documentation that came with the drive. If not, it is helpful to remember that the N stands for the number of sectors per track and the T for the number of tracks you wish to format. Although formatting must be done to all disks except those formatted during a disk copy, you should be careful that you are formatting the right disk, since all the data on the disk is erased when you do. An example of a batch file which will protect your hard disk from being formatted accidentally can be seen in Chapter 13. Although there are many different switches, the only ones commonly used are /S and /V, so you needn't bother memorizing all the options. Now, let's format a disk. Type format A, : and strike enter. Now, this is the most common format command, one which formats a diskette in drive A. You'll then be prompted to insert a disk in drive A and to strike any key to begin the format. The DOS files are not put on the disk, so you can't use this disk to boot the computer. Type N for no when asked if you want to format another disk. If you want to format your hard disk, type format C, : /S/V. Now, this formats the hard drive C and places the DOS files on the disk so that it's bootable. In addition, it allows you to place a volume label on the disk, which is helpful for identifying it later. I won't be doing this, so strike Control-C. Our next commands are the MD, CD, and RD commands. Now, these commands make, change, and remove directories. They all operate with the same syntax, as you can see. The normal way to use these commands is by specifying the full path to the directory you want to make, change to, or remove. However, if you are already working in a directory which is partway down the path you want to work with, you may use a shortcut and only specify the remainder of the path. To display the current directory, the one you are working in, type only CD with no parameters and strike enter. Note that a directory can only be removed or deleted if it is empty, that is, it has no files, including other subdirectories in it. Let's make a directory, then change to that directory and create a subdirectory in it. Type MD Lotus and strike enter to create a Lotus directory. Type CD Lotus, then strike enter to change to the Lotus directory, making it the current directory. Type MD Graphs and strike enter to create the Graphs directory in the Lotus directory. The final result is creating the C:\\Lotus\Graphs directories. Type CD \, lotus / graphs and strike enter. This will make /lotus / graphs the current directory if it exists. If it does not exist, the message invalid directory will be displayed. Now type cd, strike enter, and you'll be shown the current directory such as c:\lotus / graphs. To remove a directory, it must be empty. If you want to remove lotus graphs, you must first remove graphs. You can remove graphs because it is empty. You can't remove lotus because it is not empty. It contains graphs. First, type cd /lotus and strike enter to move to the lotus directory. Now, I moved to the lotus directory because you can't remove the graphs directory while you're in it. Now, type rd graphs and strike enter to remove graphs. Next, return to the root directory by typing cd / and strike enter. Now, type rd /lotus and strike enter to remove lotus. Now those directories you created a moment ago no longer exist. If you try to remove a directory and are told that it is not empty, you must delete all subdirectories and files within that directory before trying to remove it again. The first command in this section is the path command. This is a very important command. What it does is set up directories so that they will be searched when you want to run a program or batch file. This means that you don't have to be in the directory the program or batch file is in order to run it. And normally, you set a path to the root and DOS directories so that all the DOS commands are always available and your batch files in the root directory are always able to be run, no matter what directory you're in. In other words, all your DOS files may be on drive C, but you're currently using drive A. If you want to use a DOS command while in drive A, path tells the computer to search a certain path in drive C for whatever DOS command you want to use. It is always advisable to use the drive name in the command so that the complete path to the directory is specified. Otherwise, if you set up a path like \DOS intending the DOS directory on the C drive to be searched, but you're working on the D drive, DOS would try to search for the \DOS on D instead of C. Now, using path alone causes the current path to be displayed. Using path with a single semicolon causes the path to be reset to nothing. Setting a path does not cause DOS to search those directories for data files. Use append for that. Only files with the extensions exe, com, or bat will be searched for by path. All right, let's set some paths. Type path, semicolon, and strike enter. This resets the path to nothing, no path. Now suppose DOS is loaded on drive C, but you're working in drive A. Put a blank disk in drive A, type A:, and strike enter. A is now the current drive. Suppose you want to format the disk in drive A. Type format A:, and strike enter. You receive an error message that says bad command or file name. The computer needs DOS to format the disk in drive A, but since DOS is on drive C and you're in drive A, the computer can't find DOS. Let's use path to tell the computer where to look for DOS. Type path C:, semicolon, C:, \DOS, and strike enter. This sets a path to the root and DOS directories on the C drive. Now if you type format A:, and strike enter, the computer will be able to find DOS and will allow you to do the format. Strike Control-C to escape from the format process, since you don't actually want to format a disk. Finally, type path and strike enter to see the current path settings, such as path equals C:, semicolon, C:, \DOS. You can set the path to search as many directories as you like. Just remember to place a semicolon between each directory path you specify. The next command is the system, or sys command. This command is used to place the DOS system files, ibmbio.com and ibmdos.com, on the disk specified in the command. The disk must be previously prepared by formatting it with the /B or /S parameters. The other necessary DOS command, command:\com, must still be transferred to the disk with the normal copy command, even after a sys has been performed. You can use this command to update disks with a new version of DOS without reformatting them. Now let's use sys. Type sys A:, and strike enter. This places the system files on drive A. To put command.com on drive A, you must use copy, such as copy command :com A:. This must be done before you can use this disk to boot the computer. The next command is the time command. Now this command is used to either set or display the time held in the internal clock. If you type in time only, the current time will be displayed and you'll be prompted to enter a new time if you wish. On the other hand, you may enter the time directly as shown in the syntax without displaying the current time. DOS will automatically ask you for the date and time if you do not use an autoexec.bat file. If you do, you may want to put the time command in your autoexec.bat file. Note that the clock works in military time, so 4 p.m. is really 1600 hours. Now, check the time. Type time and strike enter. And you'll see something like this. This displays the current time to the 100th of a second and prompts you to enter a new time if you wish. If not, just strike enter. Now, type time 12:30 and strike enter. This sets the time to 12:30 in one step without displaying the current time. The next command is the tree command. This command displays all the directories on a drive. It can also display the files in each directory if you use the /F switch. Let's look at a directory tree. Type tree and strike enter. This will display the directory tree for the current drive in a format like this. Now type tree C:/F and strike enter. This will display the directory tree on drive C and also list the file names in each directory. At this point, you have seen many of the most common and useful DOS commands. In the next chapter, I'll show you more advanced commands.